Hello students, I am Dr. Tanmay Vishwash. I welcome you all in my channel Chemistry, the Mystery of Molecules. So I hope you all are fine. Today we are going to discuss application based topic of NAF carbonyl synthesis. The application of NAF carbonyl synthesis, but some other interesting reactions are also involved. Such kind of transformation I believe you should learn because MCQ could easily be constructed from such kind of reaction. Okay, so this is interesting. All the properties we have learned about organic chemistry is needed to solve such problem. So a lot of chemistry to be learned, and what we are going to learn today, first of all, this NAF carbonyl synthesis and its application to prepare 1,4-diketo compound. Why 1,4-diketo compound important? If you not forgot, I have already explained, this is a precursor for 5-member heterocycle preparation like pyrrole. Okay, so we will discuss that thing little bit also. So a lot of interesting strategy as well as recapitulation of basic understanding for the preparation of different variety of molecules we will learn. So a lot of chemistry to be learned. Please watch until the end. And another thing I suggest you, please watch the video completely, because if you skip something, you may watch what I am writing in the board, but I am saying many things which will not listen. That is mainly the logical understanding part. And if you learn the logical understanding part properly, then it will help you in the exam hall, I believe. Okay, so let's start. So first of all, in this case, I always suggest forget the headline. Look what is the reagent given, what is the molecule, what is the application possible. Okay, that's the best strategy I believe. So what is here? See, this is a nitroethane. Okay, so this is nitroethane. Just structure this why I am writing, because it will help you to remember what you learned previously. Fine. So this is the nitroethane, and this is NaOMe. Actually strong base. We know that nitroalkane has pK around, you should remember if you listen my lectures, 10. Okay, if you read regularly, this thing will, you don't need to memorize, but you know this because I didn't memorize. Around 10, like active methylene compound. Okay, so we know that if you put active methylene compound and base, this will be deprotonated to produce the corresponding carbon ion. Same thing happens. So in presence of NaOMe, this proton is abstracted and produce this, and this is resonance stabilized, means this NO minus and this. By the way, nitrogen prefers to remain in tetracoordinated state, that's why this is stable. Fine. And now question, why this is so much acidic? Because nitrogen electronegative atom having plus charge that has to 2 oxygen. That is the reason it is so acidic. Fine. Now look at this molecule. What is the uniqueness of this molecule? This is nothing but a alpha beta unsaturated ketone. Not only ketone, CO2Me, ester also. CO2Me. So you may consider that this is doubly activated. What do I mean by that? Alpha beta unsaturated carbonyl, if you look at its canonical form. So its canonical form is that it can come here and it can come, so this O minus. So what do I mean? What I mean that this is electrophilic, but this is also electrophilic. Okay, point number 1. Second, it is better to say strongly electrophilic, and what we are producing here, carbon ion. Okay, so this is actually a carbon ion, means softer nucleophile. Okay, and this has a specific unique term. That terminology is, this is a Michael acceptor. I have already discussed Michael reaction in many videos, so please visit if you feel that you feel any difficulty in understanding, because I will not explain that much details here. Please visit that video. So this is a Michael acceptor. Similarly, this is actually a Michael donor. Okay, so if it is a Michael donor, this is Michael acceptor. So simple strategy that they'll react together. And if they react, what will be the thing? So let me write it here. this minus will attack here, so it will come here, it will go. Question now, why not the other side? So simple, this is a keto-carbonyl, this is a ester-carbonyl. Ester-carbonyl has a cross conjugation. That's why I wrote in this fashion. Okay, so that is, this is less electrophilic than this. So question, what is the expected product here? So in such cases, when you are dealing a big molecule, I always suggest try to keep everything as it is, such that you can focus only the target part. Okay, so here nitroethane, this is, and what it will result? This will result double bond O minus this. So now after that, what it will result? See, it will come again. Oh, by the way, no. There should be a carbon. This should be attached to another carbon. I made mistake. This should be like that. Okay. So this carbon is this. This is the carbon we have. This is the alpha. This is the beta carbon. Fine. So this. Now question. This will come back. This will come back and it will open. And ultimately it will get protonated. From where? I'll explain just a minute. So in this case, this and here the negative charge. This negative charge is also, sorry, not here. Okay, yes, this is here. Question, this negative charge is doubly stabilized. Why? Because it is a in between two carbonyl, means like the deprotonation of active methylene group which resulted here, this. So now question, it can abstract proton from where? NaOMe, which was after this proton abstraction, it was converted into methanol. So you may consider that this is the source of proton because the other solvent is THF, so it can't give. So what is happening? It's a Michael addition reaction. Okay, so the hydrogen from this went shifted here. Yes. Fine, you have understood. Now, actually, the last step of this process. See, this is the there is another step, that is sodium methanol. Okay, so what this sodium methanol do? Actually, you have read about sodium methanol acting as a reducing agent. Okay, but it is always not true. What it can do? It can abstract the proton from this methanol and it can produce methoxide, means NaOMe. This is minus, this is plus. Just try to recall, if you haven't watched the previous video about the Nef carbonyl synthesis basic means what do I say? Aci-Nitro this nitroso keto tautomerism, Aci-Nitro tautomerism and Nef reaction, that lecture I have explained. This conversion could be done both way. One is using very strong acid and second is first base, second acid. Okay, so see, there is an ester group, this part. So if we do not take care and use very strong group, there is a chance that this ester will be hydrolyzed. Okay, so if we don't want that, that's why it is better to use a base, means basic medium. So what this basic medium will do? It is true that this proton will be abstracted, undoubtedly, but that is not focus. Our focus is that, see, this proton, this is also acidic because see, there were two protons previously. So one is consumed, another one left. So what it can result? So this is the nitro, means this canonical form will help you to understand why this is happening. This CO2Et. See, this is also a proton in between active methylene group. This is acidic, similar acidity of this. Please be careful while dealing with, because when your examiner is taking viva, means face-to-face discussion, he or she can ask, what about this? It will be deprotonated, but since it is not focus of our attention, that's why we are not discussing. So this minus will be generated. Now what it will do? It will make the tautomerism, means this. Let me clean this part. Means what is the main purpose? The main purpose is for the tautomerization. Okay, so This is the nitro form and the corresponding acid form. This is the nitro form. And the acid form is this. It will open O minus. This is O minus. CO2 sorry, CO2 is it ET? No, it's Me. This is the Me. This. Okay. This much. Now, what happened if you put sulfuric acid methanol 50 degree means very mild air condition. So this will be protonated. And C, sorry, there should be a positive charge. This will also be protonated. Why? See, there is a logically the protonation should occur on this carbon because proton was removed from, but compared to carbon versus oxygen is harder base. So proton is hard acid, so oxygen likes proton rather than carbon. Okay, but it is not that reaction will stop, but in this way reaction will go on. In next step, what is expected? In next step, see, it can push and it can leave. Okay, and another thing, point number 1, other thing that nothing anhydrous written. Okay, when such kind of thing, then so some amount of water is there in the medium. If anhydrous written, then careful. So it is better instead of this first water attack will occur. Why? See, you can compare this thing as a protonated carbonyl derivative for your better understanding. How an aldol condensation in acid medium happens? First protonation. So this and another thing, protonation increases the nucleophilic attack on the carbonyl group. Okay. This is the basic principle of aldol. So what it will result? This is proton, water, so it will attack. And ultimately it will open up. Okay. So what it results? This is N, this is OH, this is OH. I prefer to go little slower such that you can understand properly. So please tolerate if you know the thing. Okay. So after this, proton will be eliminated. It will have a formal positive charge. It will release the proton. Fine. So after this, see, after this attack, this nitrogen became neutral. Now what can happen? This can push and it can leave. Okay. So what it will result? And after pushing, it will have double bond, but oxygen will have a formal positive charge. So if the oxygen leaves the proton, ultimately it will result in this, and that proton could be obstructed by this nitrogen because it has a lone pair. This. So in next step, what it will do? It will push. It will come, and ultimately the fate of nitrogen is N2O. More details, please watch the video. So what is the conclusion of this? So conclusion of this discussion, conclusion of this many step is this. Okay. This part is actually not our interest. That's why we are not. This is a just group. Now what we have prepared? We have prepared 1, 2, 3, 4. So this is actually a 1,4-dicarbonyl compound. 1,4-dicarbonyl compound. Okay, it was our target. Okay. Now, question, as I told that I will give a little brief about its application. Means this heterocyclic preparation. For example, if you take any ammonia derivative, so you make ammonia derivative. What it will result? See, this 1,4-dicarbonyl compound, it will result in pyrrole. Let's take amine derivative or ammon, or you may consider RNH2 derivative. This and another thing, 1 for this. So in two positions, CO2, N. So this and driving force for the reaction is aromaticity. I have discussed this in another lecture previously. Please visit preparation of 5-member heterocycle from 1,4-dicarbonyl compounds. Not only this furan, thiophene, they can also be prepared. Okay, so this is the overall understanding. So what we have learned today? We have learned the mechanistic pathway for conversion of nitro into 1,4-dicarbonyl compound via, first of all, Michael addition reaction, second Neff reaction. So two reaction we have studied, Michael addition, and this step is Neff reaction. Okay, and the complete mechanism. And finally, we learned how to prepare, how this could be converted into the corresponding aromatic derivative. But what could be the application? For example, as an examiner, I can do, instead of this RNH2, RNH2 it will be prepared this. So I can prepare four options. What? That one option is this, one option is this, another option is this. Here, carboxyl not here, it is here. Another thing, just simple pyrrole, no carboxylic acid. So no ester derivative. Or another we can give that carboxylic acid. Okay, in this way. So option number 1 this is, option number 2 this, option number 3 CO2Me here, and option number 4 no carboxylic acid, simple pyrrole. So 4 option and 1 MCQ could be constructed. So such that in this way, I believe, means I am not a professional examiner, in this way question could be converted. So this is the benefit of learning such process. Okay. So this is the end of this discussion. I thank you everyone for watching this lecture. If you really like my teaching, please help my channel to grow. Subscribe my channel and please press the bell icon so that you get notification of every single video I upload. And secondly, if you think it's deserving, please pass it on to your friends so that they can also enjoy the benefit. And for my satisfaction, please like the video and make some good comments. So thank you again. Stay happy, stay blessed. See you in my next video.